Hello and welcome back. In 3.3 we continue our work with truth tables. This time on the conditional and biconditional. So the basic conditional we saw before was of the form if P then Q. So again, we have the basic two-statement truth table. So we have our true, 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 false, false, true, and false, false. So that one you already know from our work in previous sections. And again, with this one, we're going to think of talking to a kid. We've all talked to little kids at some point in our lives. So we're going to assume that we've made an if-then statement to a kid. So we'll think of it as P will be you clean your room. Q will be we will go to the park. Something fun, something the kid wants to do. So scenario number one, row number one in our truth table, the kid cleaned the room, you went to the park, you told the truth. Scenario number two, the kid cleaned the room, you didn't go to the park. Are you going to hear about that? You sure are. You gave a false statement. Number three, the kid did not clean the room. Now it's up to you whether you want to go to the park or not. So you can decide, okay, well, they did something else nice, something else useful and productive. I can still take them to the park. If the kid didn't clean the room and you didn't go to the park, you still didn't tell that child a lie. So on the conditionals, the if-then, the only way to make a false end result is right here, a true followed by a false. Anything else is okay. True followed by true is okay. False followed by anything is okay. All right, so we'll practice working with this a little more. We'll make one for if P then not Q. Sometimes the if then is shortened to implies. So P implies not Q means the same as if P then not Q. Those two are the same. So as always, if I have two simple statements, 2 squared, I will have 4 rows in my truth table. True, 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 false, and then false, true, false, false. Some other tools I'll need a not Q column. So we'll switch Q's truth values. So false, true, false, true. And we'll do an if P then not Q. Again, I'm just going to kind of highlight the 2 columns I'm now working with. So true followed by false. That was the only one we were on the lookout for. That end result is false. True followed by true is okay. False followed by anything is automatically okay in the if-then world. All right, so we'll build on that. We'll make a 3-statement truth table. So we're going to go for the negation of P and Q implies R. All right, so kind of one piece at a time. We'll get our basic initial columns done for P, for Q, and R. So remember, with the 3 basic statements, 2 to the third, 8 rows total. And you don't have to memorize 8 separate rows. If you know the 4 from the 2 statement, you're good to go. True, 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 false, false, true, false, false. Place a true in front of those. And then do that over again with a false out front. All right, so we have 2 sets of grouping symbols, just like in our algebra days, innermost to outermost. So we'll look at a P and Q. So with the and, the conjunction, both parts have to be true, otherwise the compound statement is false. So true, true, we're okay. True, true, we're still okay in row 2. Rows 3 and 4, I missed on at least one part, and result is false. Rows 5 through 8, P is false, so the conjunction is false. So that was our innermost set of grouping symbols. Then we move out to our outer grouping symbols. So then we'll do the negation of the quantity P and Q. That will switch truth values from the previous column. Negating something just changes truth values. So now we have 2 falses followed by 6 trues. So we have this one followed by R. So where I'm going to look, I'm going to start looking here first and then look at R second. So false followed by anything is true for the if-then. So the first 2 are automatically true just based on what's happening before the arrow. After that, the rest are starting with trues, so I have to check both parts of it. So row 3, we have true followed by true. That's okay, that works. True followed by false. The kid cleaned the room and you didn't take them to the park as promised. You have told a lie. True followed by true, you're okay. True followed by false, again, that's the one we're on the lookout for. True followed by true, we're good to go. True followed by false, again, that is false. So this would be our end result for the 3 simple statement involving an if-then. So I also want to work on translating a little bit. So I'm going to make a few simple statements. So P will be you drive fast. Q will be you are pulled over. R will be you arrive early. So I'm going to give you a sentence in writing. I'm going to ask you first to translate it into symbols. So if you drive fast and are not pulled over, comma, then you arrive early. That comma does matter in there, so make sure you have that copied down in your notes. All right, so first I'm going to ask you just to pause it and translate it into symbols. Okay, welcome back. So we have if, so we have some type of conditional going. Drive fast is P. Not pulled over would be not Q, and we said and. So this would be P and not Q. Those were all part of my if, so I have to group them together with parentheses. They were before the comma. I had two conditions before, one condition after. Then you arrive early. That is statement R. So P and not Q implies R. So the second thing I'm going to ask you to do is make a truth table for that. Let me go ahead and copy that, and we'll continue that on the next page. Create a truth table for what we just said. P and not Q implies R. So go ahead and pause it, unpause it when you're ready. Okay, welcome back. So here are P, Q, and R. So our tables, as usual, you just have to know the 2x2 table. 2 simple statements, 2 squared, 4 rows, and just put a true in front of those, and then repeat it with a false in front. Okay, looking inside the grouping symbols, I notice I have a not Q, so I'll create a not Q column. So instead of true, true, we'll start with false, false. Instead of false, false for 3 and 4, now we have true, true for 3 and 4. And I just continue switching the values in the Q column. Now I have a not Q column. Now I'm ready for a P and not Q column. Just to kind of highlight what we're working with. I'll just do these 2 red arrows. They're working together. So I'm connecting with an and, so I need both parts to be true, otherwise the end result is false. So that's why my first 2 rows are false. Row 3, both parts are okay, true. Row 4, both parts are true. The conjunction, the and, is true. False, false is false. And all the rest of these are going to be false, due at least due to the P, sometimes due to both the P and the not Q. So now I have everything in the parentheses. Now I'm ready for my final column. So P and not Q together, quantity imply R. So this time we're starting here, ending here. So I have a false followed by anything. That is true. False followed by anything in an if-then format is true. So I just have to pay attention to the ones that start with the true. True followed by true, we're okay there. True followed by false, that's the only way to make an if-then into a false statement. So then the rest of these start with a false, so they are automatic trues. So there was really only one way to make a false statement out of that. I have you all try another one. This one is going to be a pair of truth tables. This will use smaller ones though. My apologies. So you're going to make a truth table for P implies Q and for not Q implies not P. So go ahead and pause it, make those two tables, unpause it when you're ready. Okay, welcome back. So both of these will start with our basic 2x2. 2 simple statements, 2 squared, 4 rows. So P implies Q. Again, we're only on the lookout for a true followed by false, which would make that false. True, true is okay, and false followed by anything is okay. The next one, we're looking for a not Q implies not P. So I'll start with a not Q. I'll look back at Q and just flip truth values. I also could use a not P column, which would be false, false, true, true. And then we'll look at not Q implies not P. Again, the order of this is important. We're starting at not Q, then we're going to the not P. So false followed by anything is true. True followed by false is false. False followed by anything is true. True followed by true is true. So one thing you might notice, these are equivalent statements. This is used quite often in math to prove or disprove things. Sometimes P implies Q is too difficult, but not Q implies not P is easy to show. And we get a little bit more into equivalent statements in a little while. So next I want to look at the biconditional. That is the if and only if. You'll sometimes see mathematicians abbreviate that one as if with 2 F's, IFF. The notation. It's a 2-sided arrow. And what it really means, P implies Q, and Q implies P. So let's see what this produces. So we'll make a P and a Q. P implies Q. You've done that a few times already now. So we have true, false, true, true. Q implies P. Now we're going the other way. Start at true, end at true, we're still okay. Start at false, we're okay. Start at true, end at false, that is false. Start at false, end at anything, it's true for the if-then. So now I have both pieces. Now I'm going to put them together with the conjunction, the and. So P implies Q and Q implies P. So remember, for an and, we want both parts to be true. If both parts are true, we get to keep it. So row 1 is good. Row 2, we miss because of the P implies Q. Row 3, we miss because of the Q implies P. Row 4, though, we're good to go. So really, for the if and only if, because remember, this is what we said the meaning is. P if and only if Q. I want you to take a moment and analyze this compared with the original 2 columns and see if you can come up with when is, I'll put a little star by this, star true. You might have noticed it's true 2 times when it's either both true or both false. So in other words, when both pieces have the same truth value. So the 2 times they started with opposite truth values, the biconditional ended up false. So now that we know this little shorthand, now we can skip from writing our 2 originals right to the if and only if, the biconditional. So same truth values, it's true. Different truth values, the biconditional is false. Same truth values, biconditional is true. All right, so we'll try one more for, let's try not Q, if and only if P implies not R. So take a moment and at least get your first 3 columns done. Go ahead and pause it, unpause it when you've got them all set up. Okay, welcome back. So we have our true, 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 false, false, true, false, false. And that repeats again. True, 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 false, false, true, false, false. First 3 preceded by a true. First 4 preceded by a true. Last 4 preceded by a false. Okay, so some pieces that we'll need a not Q. So false, false, true, true, false, false. So again, I'm just looking at column Q and flipping it and ending with true, true. Inside the parentheses, it looks like we'll need a not R column. R was just alternating first true, then false. So now we'll alternate first false, then true. So we'll get a P implies not R column going. To just highlight, here's our P column, here's our not R column. So true followed by false is false. True followed by true, we're okay. True followed by false, that's the only way to make an if then into a false. True followed by true is just fine, and then false followed by anything in an if then is true. So now we're ready for the last bit, the biconditional. Since we have our not Q, we have our P implies not R. So those two columns in blue with the biconditional. So if they, remember with the biconditional, if they match, if they have the same truth value, it's true. So row 1 is true. They were both false, so the biconditional is true. Opposite truth values, result is false. Row 3, also false. Matching truth values, we're good to go. Don't match, result is false. Don't match, result is false. And the last two rows then are truths. So occasionally they have us determine truth values under just certain circumstances. So basically it's like doing only one row of a truth table. We're going to do P if and only if R implies not Q or R. And we'll do this for P true, Q false, R false. So first, I'll just sub out. So P was true. Then we had our biconditional. R, we were told, was false. That implies negation of false or false. So true, if and only if false, that is a false statement. So remember the biconditional, they have to be the same. Negation of false is true, so this turns into true or false, still in parentheses. So false implies true or false. Remember the disjunction, the or. If even one part is true, the whole thing is true. If I tell you that I am a teacher or an astronaut, I have told you the truth. False implies true is true. So this is true. And if you're wondering for the quiz, do you have to show your work to get there? Yes, I'm not looking for a coin flip. You have to show me your work. Show me how you got there. So I'm going to have you all try one. Determine the truth value. So if there are 20 months in a year, then there are 8 days in 1 week. So see if you can come up with how many simple statements that is and what the overall truth value is. Okay, welcome back. So statement P will be there are 20 months in a year. Statement Q, there are 8 days in 1 week. Put into symbols, we had an if P, then Q situation. We had a false implies false. So this is actually true. This is logically true. Couple of vocab scenarios. Self-contradiction. Compound statement that is always false. Tautology. Similar idea, but it's always true. And an implication. Conditional statement. So an if-then, that is a tautology. All right, so let's try a couple of these. Let's try P or Q or not Q. So this one, I'll just need the 4-row truth table. So we'll do a P or Q, the disjunction. If even one part is true, the whole thing is true. The only way to miss on the or is if they're both false. We'll also need a not Q column. So, not Q, we have false, true, false, true. And then we put those together. So we have P or Q, or negation of Q. So if either one of these is true, the whole thing is true. So since all of these were true, this is an example of a tautology. Next we'll try out P and Q implies P or R. So we'll need our P, Q, and R. True, 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 false, false, true, false, false, and repeat. Four trues, four falses. So we'll do a P and Q. So an and, a conjunction, we need both parts to be true for the end result to be true. So the first two rows, we're good to go. Second two rows, we're out of luck. Rows 5 through 8, out of luck. We start with a false. We'll need a P or R. This time a disjunction. The only way to make it false is if both parts are false. So automatically these first four are true because of P. False or true. We're okay because of the R. False or false. That's false. False or true. That's true. And a pair of falses is false. So now we have everything we need to do the if-then thing. So P and Q implies P or R. To scooch over a little bit. There we go. So we're going in order here. So true followed by true, we're okay. True followed by true, we're okay. False followed by anything is automatically true. So this one is an example of an implication. It was an if-then statement where everything turned out to be true. A very simple self-contradiction, P and not P. There's just one simple statement. You only need two to the first two lines, a true and a false. Not P would be false, true, and putting them together with an and. Remember, an and, a conjunction, we need both parts to be true for the end result to be true. So that is a self-contradiction. All right, so that should give you enough ammo to play with section 3.3. So we'll do 1 to 6 all, 7 to 73 on the odds. If you have any questions, please get in touch. Otherwise, I will see you next time, and stay safe out there.